Let's see part 4 of quadrilaterals chapter now. Section 7.4 of our textbook, properties of quadrilaterals. In the last video, we learnt about different types of quadrilaterals, that is trapezium and kite, plus parallelograms, that is rhombus, rectangle and square. In this video, we'll learn some properties of parallelograms and prove theorems related to the same. So we'll be seeing, as I told in the last part, we'll be seeing one by one property in each video and then prove one or two theorems related to that property. So this is, the property name is congruent triangles property. Let us see what is that. ABCD is a triangle. ABCD is a parallelogram. A parallelogram is basically a pair of congruent triangles with a common base. You can see that now. Let us prove the same. In parallelogram ABCD, join AC to form a diagonal. As discussed earlier, this divides a parallelogram into two triangles. So we have joined the diagonal, that is we have joined points A and C, vertex A and C. So now what happens? Two triangles are formed. This is what we saw in the quadrilateral also. AB is parallel to DC. It's already given, correct? Parallelogram definition says AB is parallel to DC, AD is parallel to BC. AC is a transversal intersecting both the lines. Now we are going back to which chapter? Yes, lines and angles. So in lines and angles, we saw what is a transversal. We saw some axiom and we have proved some theorems. So now you can consider line AB parallel to line DC with a transversal AC intersecting both of them. So what happens? Angle DCA equal to angle BAC. That is as per alternate interior angles theorem. I will put the angle also in the drawing. So you can see DCA and BAC. One more thing, what we have been seeing in angles, in lines and angles theorem itself, and in triangles also we have seen, the path is very important, the root is very important. So see the way it is told, DCA, it is not DAC. So if it is DAC, the angle will go in a different direction. So it is DCA and BAC. So these two angles, because of alternate interior angles theorem, both are equal. Let's go to the next page. You need to note down these points before you move to the next page. Now what we are seeing, similarly, AD parallel to BC with transversal AC intersecting both the lines and angle DAC equal to angle BCA. So I am putting a different color here. You can see that now you can see AD is parallel to BC. So what happens? Between AD and AC and between BC and AC, two angles are formed, two alternate interior angles are formed, both are equal. Now because of this, therefore triangle DCA and triangle BAC, that is triangle DCA at the top, triangle BAC at the bottom, both are congruent. The reason is two corresponding angles are equal. Already we have proved that you can see the pink color angle and the blue color angle. Two corresponding angles are equal and AC is a common line, which means diagonal AC bisects the parallelogram into two congruent triangles. So this is what we have seen now. Now AD equal to CB. Why AD equal to CB and AB equal to CD? Because of CPCT. So in this page I am explaining in detail so that even if you have slightly forgotten this congruence and CPCT is corresponding parts of congruent triangles, so that you will be able to recollect very well. From the next theorems onwards, I will not be explaining in detail. I will simply show only the wordings here. However, the wordings, whatever is mentioned here, that will be there in all the theorems, but I will not be explaining to you as I am explaining in detail in this part. So now what has happened? We have now proved the top triangle and bottom triangle are congruent by first proving the alternate interior angles, and now because of congruent triangles, the corresponding parts of congruent triangles are equal. So AD equal to BC or AD equal to CB and AB equal to CD. So that we have now proved it. So because of this, what happens? This also I am putting for your ease of reference. AD and BC I put single red dash. Here I am putting double red dash. So now these two opposite sides are equal. Therefore, each pair of opposite sides is equal in a parallelogram. So we are going to see two theorems now. That is, one is diagonal AC bisects the parallelogram into two triangles, two congruent triangles, and each pair of opposite sides, that is each pair, you have to note down this point, each pair, that is AD and BC are one pair, they are equal to each other. Similarly, the other pair is AB and CD, they are also equal to each other. So each pair of opposite sides is equal in a parallelogram. One pair is parallel is not sufficient. One pair parallel means what? Yes, if it is only one pair is parallel, then it becomes only a trapezium. So both pairs of the parallelogram, both pairs of a quadrilateral has to be parallel to each other, then only it is called a parallelogram. So now you have to in detail note down these points in whatever way you understand before going to the next page. Let's move to the next page. Based on what we saw now, we get the following theorems. 7.1, a diagonal of a parallelogram divides it into two congruent triangles. That's what we saw in the previous page. In a parallelogram, opposite sides are equal. Correct? These two we have proved in the previous page. Now this shows one converse. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. That is 7.3 is a converse of 7.2. Hope all of you know what is a converse. That is, if one is given, the other is proved, and if the other is given, the first one is proved. That is, 7.2 says in a parallelogram, opposite sides are equal. 7.3 says if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. That is the converse. The other direction is also true. If one forward direction is true, the return direction is also true. That is what it means. And note this point. Theorem numbers mentioned above are not standard numbers but given because of chapter number. This I have been telling every chapter. I will tell this at least once. I will tell, so that by mistake also you should not get confused with the number. In some other book or somewhere else, if you see some other 4.3, doesn't make any difference. It is the explanation that is more important. If each pair, so whenever you write the reason, don't write the theorem number. Only in some questions I might have asked, that's only for your reference. But when you write the theorem, you can also see wherever I have proved any theorem and written any reason, the reason will be either a brief detail, opposite sides of a parallel quadrilateral is equal, like that I will write. We will not write the theorem number. So for that only I have mentioned this note again in this chapter also. So this is same in the case of all theorems. Everywhere it will be, this will be followed. So now there is a proof for 7.3 theorem. That is the converse of 7.2 we are going to see now. Given a quadrilateral ABCD with opposite sides equal, that is AD equal to BC and AB equal to DC, we will see the triangles DCA and BAC both are congruent. The reason is SSS congruence rule. Two sides are equal, already we have seen that is given, and the third side is a common side. Now because of this, what happens? We are seeing that four angles, that is DCA and BAC. I will put the colors also. Blue color, DCA equal to BAC. Similarly, DAC pink color and ACB or BCA both are equal. The reason is corresponding parts of congruent triangles. Therefore, DC parallel to AB and AD parallel to BC. Converse of alternate interior angles theorem. So you see everywhere in the bracket I am writing the name of the theorem in brief. Should not write the number. So one more theorem we have used, and we are now showing the DC parallel to AB. You can make out it is a converse. Again, for proving the converse, we are also using converse of the alternate interior angle theorem. Since each pair of opposite sides is parallel, quadrilateral ABCD is a parallelogram. So now we have come to the proof. So we are able to prove that if each pair of opposite sides are equal, each pair of opposite sides is parallel, then the quadrilateral ABCD is a parallelogram. Correct? So what we have seen, the given is, we have been given that opposite sides are equal. Since by proving that opposite sides are equal, through the other two theorems, we are able to show that each pair of opposite sides is parallel, because this is the definition we have seen in the flow chart. So to prove that the opposite sides are equal, we have used two theorems, and finally we are concluding based on, since each pair of opposite sides is parallel, that is a basic definition of a quadrilateral, of a parallelogram, quadrilateral ABCD is a parallelogram. These are all very important points. You can pause the video and note down the points before moving forward. We'll move forward. So in this video, we have learned some properties of parallelograms and proved theorems related to the same. So two main properties we have learned: diagonal divides a parallelogram into two congruent triangles, opposite sides are equal, and also its converse. So basically we have learned three theorems. We have proved three theorems in this part. In the next part, as I told earlier, we will be learning some more properties, and whatever properties we learn, we will be proving the theorems also. Some questions. Pause the video, note down the points, note down the questions. That's all for this video. Thank you.